Okay. Okay. Is this visible?
Yes, sir.
Okay. No. So let's start now. So this is basically a two-body problem. What two-body problem means? That we have two masses m1 and m2.
Sir, your voice is not clear.
Someone they are trying to join. That is why I get interrupted. So we have two masses m1 and m2, and this is some frame, inertial frame. So you can think of these two m1 and m2 some like earth, moon, or some earth and sun, or maybe moon, sun. So anything you can consider these m1 and m2. But here we have supposed these two m1 and m2 to be point masses, and there is some inertial frame. By inertial frame, I mean this frame is fixed and it is not translating or it is not rotating. Okay. So R1 and R2, these are the instantaneous position vectors for M1 and M2. So R21 is the position vector, relative position vector of M2 with respect to M1. And by definition, of addition of vectors, we can write this R21, that is the position vector going from M1 towards M2. So we can write this as R2, sorry, R1 plus R21 equal to R2 by triangle of addition. So from there you can say that this R21 is nothing but R2 minus R1. So this is the relative position vector of M2 with respect to M1. So now what is the thing which we are looking for? So we are looking that we are throwing these M1 and M2 in this inertial frame space, and we want to see how they will interact with each other. What will be the trajectories of this M1 and M2 given some initial condition and only the gravitational force being there acting on them. So that is the purpose of this whole class. So we will try to find the position vector r1 and r2 as a function of time. Uh, mm, and that doesn't mean that we will analytically solve these r1 and r2, because I have already mentioned that the purpose of this course is to solve the problems using numerical methods and using the MATLAB tool. So the purpose is that we have to find the equation of motion, and by writing the equation of motion, I mean that we have to find the relation between the time and the position vector r1 and r2. So if we see m1, there is only one force, and the force is being applied by this m2, and that will act towards m2. So I have written it as F12, that is force acting on first due to second, and this will act towards M2. And similarly, F21 is the force which is acting on second mass, and it is being applied due to M1, and therefore it will act towards the M1. Is this clear up to this? Every notation and other things are clear? Are some questions? Before we proceed, I want that everything is clear.
The inertial frame means that A is 0 or V is 0. Acceleration is 0 or V is 0.
What?
Inertial frame.
No, no. Oh, to be specific, acceleration should be zero. That is why I told you that it's rotation. For example, I told you that it is fixed, but it need not to
Yeah,
be fixed. It can be a translatory frame, but its
constant
acceleration should be
0.
zero. Why? Because only in inertial frame the Newton's laws which we will be applying are valid. So that is the reason I am considering the inertial frame. And we will see how we can define these inertial frame when we will take Earth and Moon system. Okay. So is it clear?
Yes, sir. Yes.
So acceleration is the thing which determines whether it is an inertial or non-inertial frame, not the velocity.
Not the velocity.
Yeah. So first, let us apply the linear momentum balance equation for this mass m1. Linear momentum balance is another name for the second law. So if you are comfortable with second law, you can think that we are applying second law. Okay, or you can say that we are applying linear momentum balance. I was also comfortable with the second law, but so F12 is the net external force on M1. Yeah. Any question?
Sir, voice was not clear, sir, for 5 or 8 seconds.
Okay. So others, am I audible or you are also facing the same problem? Yeah, hello. Mutawakkil, Rashid, or Said Ikra, can anybody unmute and tell me whether you are also facing the voice problem or
Yes, sir, there is some voice.
hello? Yeah, yeah, Rashid.
बीच बीच में हो रहा है सर
अच्छा बीच बीच में हो रहा है वॉइस ब्रेक हो रहा है ना
Just for 5 to 8 seconds.
अच्छा 5 to 8 seconds ओके तो जब हो ऐसा हो जाए बीच में प्लीज लेट मी नो दैट माय वॉइस इज ब्रेकिंग बिकॉज आई विल I cannot find that you are not able to hear me. And it is important because if in between the voice is breaking and you are not able to understand what I am saying, so you will lose the track. Okay. So now I am clearly audible.
Yes, sir.
Okay. Okay. So I was telling that F12 is the force which is acting on this mass M1 and it is directed towards M2. Okay. Now I am applying Newton's second law. You can also alternatively call it as linear momentum balance equation, which says that the net external force, that is F12, is mass times the acceleration. Mass of this is M1 and acceleration is A1. Okay. And for M2, we can similarly write F21 equal to M2 into A2. From these two, we can find acceleration as F12 upon M1 and A2 equal to F21 upon A2. So don't forget that we are trying to actually find the position of these two masses as the function of time. Okay, and for that we know from the first lecture that we need acceleration, because if we have acceleration we can integrate it to get the velocity, and if we have velocity we can integrate it to get the position. That is why I am trying to solve these equations for acceleration. So we have got a1 and a2, but the thing is that we don't know f1 2 and f21. So next we will be seeing what is f1 and f2. So you can see, okay, so there are some notations. So this mod of f12 represents the modulus value of the force, or the second norm of the force, uh, and the modulus value of f12, that is the force acting on first due to second, is equal to the force acting on second due to the first. And I have denoted these things as f12 and f21. And by universal gravitational law, we can say that this magnitude is nothing but g times m1 m2 upon the separation between the two. R21 is nothing, if you can see from here. R21 is nothing but the relative position vector of m2 with respect. So if I take the modulus of that, it will give me the separation between the two. So this is from the universal gravitational law. Okay, and G is the universal gravitational constant whose value is 6.67 in 10 raised power minus 11 Newton meter square per kg square. Okay. So now if we combine this with the Newton's third law, so we know the magnitudes are same. And from Newton's third law, we also know that the direction is opposite. So if f12 is acting in this direction, f21 is acting in this direction. Okay. So this is the consequence from this is the consequence f12 equal to minus f21. So from equation first, which is this equation, which was representing the accelerations, we can write that the acceleration a1 is nothing but gm1 m2 upon separation square m1 r2 1. Why r2 1? So it is because this force, see f12, if you can see from this figure, f12 is force acting on first due to second. So it will be in this direction. So it will be in a direction from m1 to m2, and that is opposite to the direction. So that is in the direction of r21. So you can say that is why I have written r21, and I am dividing this by r21 to get the unit vector, and then I am multiplying it with the r21 square, and it is becoming r21 cube. So this is actually modulus r21, it is cube here. And similarly a2, it is opposite to this force and having magnitude same, so I have put negative sign. Now we have everything. Now we have acceleration, we know g, we know m1 m2. uh, uh, so now we can integrate these equations to get what we require, that is the position vector of both these both these uh, uh, both these masses. So can anybody tell me that I'm saying that now we have the equations for acceleration, but the thing is that here r21, which is the relative position vector of 2 with respect to first. So in order to get the acceleration a1 and a2, we should know this r21. But this is what we need. So how we are going? How am I saying that I know now acceleration, even though I am not knowing what is the value of r21? Because r21 is nothing but r2 minus r1, and that is what we are finding. So can anybody tell me? Yeah, is my question clear first? respond to that.
Sir, repeat the question.
Oh, so my question is that I am saying now I have acceleration. Acceleration is this. I will integrate it to get the velocity, and then I will integrate the velocity to get the position. So if I integrate a1, I will get v1. If I integrate v1, I will get r1, and that is what I mean I am in need of. But the thing is that there is r21, and r21 is nothing. In order to calculate this acceleration, you need r21. Everything else you know, m1 you know, m2 you know, g you know, but r21 you don't know, because from the definition of r21, it is nothing but r2 minus r1. So we don't know what is r2 and what is r1. That is why we are calculating acceleration. We are integrating it, and then we are integrating velocity to get r1. So what is going on? How we will proceed from here? Now is the question clear?
Yes, sir. It's clear. Yes.
Okay. So tell me what is the way? Mutawakkil and Rashid, are you there?
Yes, sir.
Yeah. Yeah. So tell me, no, you don't need to mute yourself. Just be unmuted. Mutawakkil? Yeah.
Yes, sir.
So have you understood my question, what I am saying? Or
Yes,
not?
sir.
Be honest. Have you fully understood it?
Yes, sir.
Yeah. You need not to be worrying, and you need not to tell anything which you don't understand. If you don't understood, you can tell that I have not understood the question. Okay, so my question is, I will again repeat the question. I am saying that I want to find the position vector r1, and to find the position vector r1, I need acceleration. Once I got the acceleration a1, I can integrate it to get v1, that is velocity 1. So I will integrate that v1 and I will get r1. But the thing is, in order to get the acceleration a1, I need r1 in advance, isn't it? Because r21 is nothing but r2 minus r1. So I don't know r1. How can I find a1? Yeah, go ahead. Mutawakkil,
Yes, sir.
anything you want to say? Okay, repeat the question which I have posed.
हमें ये R1 की इंटीग्रेशन करके V1 मिलता है, तो हमें R1
Yeah.
मतलब
हम्म।
हाँ,
हेलो।
yes, sir.
हाँ, आपकी आवाज बीच में कट के आ रही है। हाँ राशिद,
आपने सर अभी बोला कि हमें R21 फाइंड करना है, ताकि उससे हम एक्सेलरेशन फाइंड कर सकते हैं और इसी एक्सेलरेशन को इंटीग्रेट करके हम वेलोसिटी निकालेंगे।
हाँ आपकी बात ठीक है, लेकिन मसला ये है कि ये जो एक्सेलरेशन हमने इसकी जो इक्वेशन लिखी है उसमें r1 भी है, तो r1 हमको पता ही नहीं।
R1 तो है ना हमारे पास, जिस फ्रेम से हम उसको मेजर कर रहे हैं।
हमारा पर्पस ये है, अगर आप देखोगे हमारा पर्पस क्या था, क्वेश्चन क्या था हमारा, फर्स्ट क्वेश्चन है कि ये जो r1 है ये हमें नहीं पता है, तो यही हमें r1 क्या है, इट इज द इंस्टेंटेनियस पोजीशन
तो
ऑफ m1, वी नीड क्या गो
R1 पता है सर,
वी डोंट नो r1,
हमें
we don't
R2
know
पता
r we don't know r1, we don't know r2, these are the
है,
things which we are looking for, which we want to calculate.
बट हमारे पास R21 तो फिक्स है ना।
No, that is not fixed. See, we have thrown these m1 and m2 in air, okay, in space. Now they are attracting each other. Do you think that R21 will remain fixed?
No.
No, because they are attracting each other. And when they will attract each other, this R1 and R2 will automatically change. And with time, how they are going to change, we don't know. And that is the question which we are trying to address. So we need to find R1 as a function of time. We need to find R2 as a function of time. And for that, I am saying that we can find these if we know the acceleration. And somehow we were able to calculate we were able to express this acceleration like this. So we can integrate now this function, integrate this thing to get the velocity, and then we will integrate velocity to get the position at any point of time. But the thing is that here in this expression, we already need this position vector, which is R21. That is the position vector of R2 with respect to R1. So we need R2 and R1. So how this we will address? राशिद, अब क्लियर है आपको मेरा क्वेश्चन?
जी सर।
हमें पता है कि हमें R1 और R2 जो है हर इंस्टेंट ऑफ टाइम पे ये चेंज हो रहा है, और विद टाइम ये कैसे चेंज हो रहा है, इनकी वैल्यू क्या है, वो हमारा वही हमारा पर्पस है कि हम वो निकाल पाए. दैट इज व्हाट वी मीन बाय द इक्वेशन ऑफ मोशन. बट अभी हमने जो एक्सेलरेशन निकाली है तो हम उसको इंटीग्रेट करते हैं, लेकिन उसमें भी जो है हमारा पोजीशन वेक्टर है, हमें तो पोजीशन वेक्टर पता ही नहीं है. इकरा,
जी सर.
आपको क्वेश्चन समझ आया?
जी सर.
आपको क्वेश्चन की क्रिटिकलिटी समझ आई कि
जी सर.
मसला क्या है? ओके,
जी
मुस्तफा,
सर.
कैन यू से समथिंग अबाउट how we will integrate this and how we will get the solution?
No, sir.
Okay, it is okay if you don't know the answer, but the thing is that you should understand the problem, where the problem lies. So the problem is, see, I will give an example. I am saying he is telling me he
Your
is the father of, okay,
voice is not clear. Repeat.
why is it not clear? Okay, now
Now
is
it's
it
clear.
okay? Okay, I will. Okay, just a minute. I will change. Maybe no, but it is already ISC LAN 2. Now is it clear or not?
Yes, sir.
Clear? Okay. So okay, I was telling that I met someone and I told him who was the person, and he told me that the person was Ishfaq. Okay, and I again tell him which Ishfaq. He tells me that, say for example, uh, he is from ISC. Okay, and I again tell him what ISC, and to explain what ISC is, he tells me uh, where Ishfaq is uh, taking his PhD. Okay,
Okay.
are you getting me?
Yes, sir. Yes, sir.
Hello. Oh, my voice is clear.
Yes, sir. It's clear.
Okay. So basically I was saying that someone tries to give my description, and he tells someone that the person is Ishfaq, and he again tells him who Ishfaq, I don't know. He tells them from ISC, and he again asks what ISC, and then to describe ISC, he is saying that where Ishfaq is studying. Okay, so this loop is, there is a loop. Okay, you are going to define some unknown in terms of another unknown. So there is the problem lies here. Same is this problem. So I am saying that I have got this A1, but the thing is that there is this unknown R21 and R2. Okay, so how we are going to solve this? What we will do is, okay, initially, see, there is difference between saying that I know R1 and R2 and saying that I know R1 and R2 initially. Okay, these are two different things. I don't know R1 and R2 at any instant of time, but surely I know what is R1 and R2 at t equal to 0, because when I put these M1 and M2, I have put them somewhere. So I know where I have put M1 and M2 initially. Okay. So I know R1 at time equal to 0 and I know R2 at time equal to 0. Okay. So with starting time, I know R1 and R2. When I say R1 and R2, that means I know initially what is R21. So initially I am knowing this thing. Okay. So at t equal to 0, I know this thing. Therefore, at t equal to 0, I know A1. And when I know A1 at t equal to 0, I will integrate it for the future time. That is, for example, at t equal to t1. This is what we have been doing from the first lecture. So if we know the current value of something and we know the derivative of that thing, we can predict the future value. So we know what is the value of acceleration, which is dv upon dt at t equal to 0. I will integrate this thing to calculate the velocity at the next instant of time. And again, then when I find the next instant of time, I find the velocity, I will integrate that thing to get the future value of position vector. So now I have position vector at next instant of time. I will again put those position vector in this equation to get the next velocity. Integrate it again to get the next. So this will keep going. Okay. Is it clear or I have to explain it again? Yeah, Rashid? Hello, Rashid?
Yes, sir.
क्लियर है या मुझे दोबारा बताना पड़ेगा?
Yes, sir. Clear है.
Clear है? So initially
Yes,
we
sir.
have to initialize this equation. Otherwise we cannot go ahead. Okay. Mutawakkil?
Yes, sir.
Okay. Mustafa, any question before we
No, sir.
proceed? Okay.
Sir, it is
Okay.
it is Krishna.
Okay. Okay. So now we are ready to simulate this thing, but before going and try to simulate this thing a little bit more, so I will define this R21, that is the position vector of second mass with respect to the first mass, as R, and modulus of that thing is R. Okay. Then acceleration A1, see from here, M1 and M1 will be cancelled, and this will be gm2 r upon r cube, and A2 will be this thing. Okay. So okay, these things you know, A1 is nothing but V1 dot, A2 is V2 dot, and V1 dot. Okay. So now I am trying to so we know acceleration is V1 dot, acceleration A2 is V2 dot, and V1 is equal to R1 dot, V2 is equal to R2 dot. So we will integrate this thing to get V1 and V2. We will integrate this thing to get R1 and R2. So I am now defining a single vector Z, which will store R1, R2, V1, and V2. And at any instant of time, we know actually the derivatives of this thing. We don't know this. We don't know R1, we don't know R2, we don't know V1 and V2. What we know is derivatives of this thing. That is R1 dot, which is actually velocity. R2 dot, which again is velocity. V1 dot, which is acceleration. V2 dot, which is acceleration. So you can see V2 dot is A2, and from here we have the expression for V2 minus gm, okay, minus gm r upon r. So A1 is this. So you will integrate these two things to get V2. So you have also V2. You will integrate this to get V1. So you have V1. So basically at any instant of time, you have this Z dot, but you need Z. So you have Z dot, you will integrate it in OD to get Z. So Beauty of the ODE
सर
is that,
एक सेकेंड
yeah,
सर आप जो लिख रहे हैं वो नहीं दिख रहा है
अच्छा, okay. Let me confirm from
दिख रहा है
others.
दिख रहा है
जी
दिख रहा है?
हाँ
अब
Yes.
दिख रहा है?
नहीं सर अभी भी नहीं दिख रहा
अभी भी नहीं दिख रहा है। राशिद, is it clear? Are you able to see what is there on the screen?
Yes, sir, it's clear.
Okay, so Ikra,
जी सर
when it happened, just before few seconds or
वो सर स्टार्ट से ही नहीं दिख रहा था
तो बताया क्यों नहीं?
तो मुझे लगा शायद बीच में प्रॉब्लम हुई है मुझे ही लगा था
तो मैंने पहले ही बताया ये जो ऑनलाइन सिस्टम है इसमें ऐसा ही हो जाता है, तो इसलिए मैंने बताया किसी एक को भी अगर प्रॉब्लम होती है तो बताया करो, क्योंकि हो सकता है दूसरों का ठीक चल रहा हो खाली आपका ये हो रहा हो, तो आप we will 2 minutes, okay, you log out and then try to log in again. Till then I will ask question if they have any.
Sir, v1 is the initial velocity of the particle, sir. v1. Hello.
Hello,
Yes, sir.
hello Ikra. Yeah. Okay, let me admit her first. Hello Ikra. Hello.
जी सर
Is are you now able to see?
यस सर
Okay. पहले किया होता तो पूरा क्लास समझ में आ जाता. Okay, but it is okay. Mustafa, you are saying something.
Okay, it is clear now, sir. I was saying that, sir, is the v1 velocity at a initial velocity of the particle at r1.
No, 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 no. No, 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 no. V1, A, see the index A1 and 2, these represent the first mass and second mass. These are not the initial values. Whenever I try to write the initial value, I will write 0. Okay, so if I have to write the initial value of V1, I will write V1 of 0. So these are not the initial values. These are the instantaneous values for the velocity of m1. This is the instantaneous value of position of m1. This is the instantaneous value of r2 of sorry, position of m2. Instantaneous value of velocity of m1. Okay, these are the instantaneous value and not the initial value. But in order to integrate this thing, we need the values of all these things initially. So you will see from the animation how we will initialize this. Okay. So
Okay, okay, sir.
okay. So we have these two equations, A1 and A2. So A1 and A2. So this is all what we have, and this is sufficient to animate this thing. But um, for the completeness, I am going to show you one more thing. So we will try to subtract A2 from A1. Sorry, we will subtract A1 from A2. So when we try to do this, A2 minus A1, and by definition, acceleration A2 is nothing but double derivative of R2, and A1 is nothing double derivative of R1. So this is R2 minus R1, and this is the double derivative of this thing. Okay, and R2 minus R1 is nothing but R21. We have seen this, and R21 I have defined as R from this. You can see R21 I have defined it as R. So just R is nothing but the relative position vector of mass m2 with respect to m1. And if we take the double derivative, R2 double dot is nothing substituting from this, that is the expression A1 and A2. You can see minus gm1 r upon r cube minus this thing, and when you take common this g and r upon r cube, we will get this expression. Okay, this is simple. You can do it on your own. That's why I am rushing in. So now, if we suppose that mass m2 is very, very less than m1, that is the second mass which is there is very, very less than m1, and this is reasonable. If we are, for example, looking for the satellite, the mass of the satellite is very, very small as compared to the mass of the earth. So here this assumption holds very good, and when we do this, we can see that m1 plus m2 is nothing but m1 itself. If m1 is very, very greater than m2, this addition we can replace by m1, and then this r double dot will become equal to minus g m1 r upon r cube, and I define this, we define this g m1 as mu. See, g is the universal gravitational constant and it is fixed. m1 is the mass of the earth and it is also fixed. So this is a constant. I replace this constant by another constant mu, and r double dot is now nothing but mu upon r cube into r. So this is what is known as the two body equation, and it is very useful for the satellite purpose. Okay, so this was just for the completeness to show you. So let us move to the MATLAB. I hope that MATLAB will run uh, and see how the things work. Okay, how we are going to simulate these things. So is this code visible to you? Yeah.
No,
Can
sir.
anybody?
Not yet.
Yeah. Not yet.
No, sir.
Okay. Let me see what I can do. Uh, oh, it is not able to. Okay. I hope now it will be visible now. Okay. Now is it visible?
Yes, sir. It is visible.
Okay. So two body problem. Yeah. The MATLAB code is visible.
Yes, sir.
Ikra, are you also able to see MATLAB code is there
Yes,
or
yes,
not? Okay, so
yes.
everyone is able to see. Okay, so even if you have not attended the previous classes, but I recommend you should. If you follow the code, I hope you will get some understanding. Okay, so there are few things which are not that much important, but as the course proceeds, your code will tend to converge this type of coding. So initially you don't need to do these things. For example, I have written animation speed. You don't need these things. But uh, at this point of time, you just remember that this animation speed represents how fast your animation will run. Okay. This T end, this is the time for which you want your animation to run. So 12 into 60 into 60. You multiply this thing and you will get something, and that is what. Okay, let's do it. So 12 into 60. So you can see in command window I have written 12 into 60 into 60. But if I run it this whole thing, okay. So 43200. So I can copy it. I can paste it here. Okay. So T end is 432,000 seconds. This for this amount of time you want to run your animation. Why this large amount of time? You will get to know soon. So this is mass M1. P is so I have written this P dot M1 and similarly P dot M2, P dot G. So this is actually a structure. P represents a structure. And by structure, what I mean that this variable P can single simultaneously hold the values for different variables. For example, it can store mass, it can store M2, it can store G, it can also store other things. But if you like individually store M1 equal to this, M2 equal to this, and G equal to this, so you are creating three variables. And if you want these variables somewhere else, you have to call them one by one. But I am defining structure. A structure will store all these values in one variable. Okay. So I will not call this as a variable. This is a structure. P is a structure. Okay. So think it as that this is simply M1. So M1 is 10 to the power 24. You know it is the mass of the Earth. M2 I have put it as 1. So I have considered the satellite's mass as 1 kg. And this is the universal gravitational constant, which is 6.67 in 10 to the power minus 11. Okay. Now this is see, I am again emphasizing on this thing that this is a structure. If you are not able to grasp it at this point of time, think there is no P, only M1 equal to this, M2 equal to this, G equal to this. Now R10, what is R1? It is the position vector of first mass. And if I am writing 0 in the last, it means it is the position vector at t equal to 0. R1 is the position vector of first mass, and I have put 0 on the end. This means that it is the position vector at t equal to 0. Okay, this is the way I am writing it. You can write something else. You can write R1T0, that is R1 at t equal to 0. Okay, and this is the position. Someone may ask that why this position. Okay, so these are the questions maybe we will address when I will play the animation. So, but at this point of time, you need to understand what the code lines are, how I am writing these code lines. So this PR10 is the position vector at for mass M. What is this is 200, x coordinate is kilometers, its y coordinate is 200 kilometers. I okay, let me
Sir, voice is
will
not
be
clear.
yeah.
Voice is not clear.
Why is it not clear?
Repeat previous 25 seconds.
Okay, okay. I will just a minute. I try to. So I was saying that position vector. Okay, P dot R1. This is 200, 200. Okay, so let me explain a bit about this. I know I have already explained it, but let us go and try to understand this 1 second. So we have We have this M1 and we have this M2. Is this whiteboard visible to you?
No, sir.
Oh, whiteboard is not visible. I'm writing something.
MATLAB is visible only, sir. Only MATLAB is visible.
Oh, there is a problem. Okay. It is very misfortunate. I can present only one thing at a time. The thing, I don't know why today this is happening. Uh, okay, let's first. Okay, let me explain here. There is some problem. I don't know. So I was saying that we have to define the parameters. That is, what is the mass, what is the M2, what is G, what is the initial value for the position vector. So this is the initial value for the position vector. And position vector, you know, it has two components. X component, this is the X component of position vector. This is the Y component of the position vector. So initially the position vector has this much along X-axis and this much along Y-axis. Okay. And similarly, the position vector of mass M2 at t equal to 0 is this thing, that is 6,000 kilometers. See, again, I am saying that I am multiplying this 1,000 so that I can get a feeling that how much distance this is. So 6,000 kilometer, 8,000 kilometer. These are the initial positions for the mass M2. Okay. D is the norm of P minus P, P R1 minus. So this is actually R1 minus R2. So if you subtract the R1 and R2, you will, and take the norm of that thing, you will get the distance. So this is the distance between M1 and M2 at t equal to 0. Okay. And then I am defining some perpendicular. These 2-3 lines you don't need to understand, because this is for the purpose of defining the initial velocity, which you can give arbitrarily. Okay, so first line, this R12 perpendicular, R12 per unit, and perturbation. These 2-3 lines you can skip, even then your code will run easily. Okay, so V20, this is V10, this is the initial velocity of your uh, mass, and V20, this is the initial velocity for your second mass. Okay, what is the initial? So basically I have put the earth stationary, and I want to see how my satellite will move. So this is V10 and this is V20, and then I am trying to put this in the vector form. That is why I am written P dot V10. See, instead of these things, you can directly write P dot V10 is something you can write as X coordinate and then Y coordinate. Okay. Instead of these two things. And then I am starting the time, and then P span, which is 0 to T end. We already defined T end like this. Okay. And now the main thing of our code is our RHS. That is, we have to find the Z dot. Okay. So remember, when we are trying to define any function, we have to define it at the end of the code. So this is the end of the code, and this is the beginning of the code. So function is Z dot myself. So you have to remember those equations which I derived for A1 and A2, because at this point of time I am not able to uh, present uh, different like PDF, MATLAB, and other things which I used to present simultaneously, but I don't know what happened today. So you have to keep in mind what was A1, A2, and A3, and here I am going to show how we will be calculating Z dot. Okay. So M1, see, the inputs for this function is nothing but time, Z, and P. So if you are giving it the input time and you are giving it the Z value, that is R1, R2, V1, and V2 at particular instant of time, and you are giving it the value of P. So what P was storing? it was storing M1, M2, M1, M2, G, and initial position. If you are giving these things to this function, it will give you the value of Z dot. So how it will give? The code is here. So basically Z dot is nothing but R dot and V dot. So, and R dot is nothing but R1 dot and R2 dot. See, I am breaking this code. I am saying that our Z dot is position rate and velocity rate. Velocity rate is nothing but acceleration. Position rate is nothing but velocity. So basically, Z dot stores what is velocity and what is acceleration. But you know that there are two masses, so there will be two velocities. So you can see R dot is R1 dot and R2 dot. Similarly, V dot is V1 dot and V2 dot. Okay, so I am back propagating. This is, I think, good way of coding things. So we know Z dot is R dot and V dot, but we know R dot, R has two, R dot, there are two masses which is R1 and R2. So there will be R1 dot and R2 dot. Similarly, V dot is V1 dot and V2 dot. So R1 dot is nothing but V1, R2 dot is nothing but V2, V1 dot. What is V1 dot? Are you there or somewhere you have lost? Mustafa, can you comment?
No, sir.
Yeah.
We are here. Sir.
So you are following, yeah? If you
Yes,
are
sir.
not
Yes,
able
sir.
to follow at any point of time, please let me know, because sometimes I rush and I think that you are understanding. Rashid,
Yes, sir.
are you following what I am saying? Are
Yes,
you
sir.
are cooking tea?
Sir?
You are making tea?
No, sir.
Okay, there was background music. I think it is from the preparation of tea is going on.
No, sir. No.
Okay, okay. And Ikra, are you also following what I am saying?
Yes, sir.
See, okay, see, I know you are saying yes, yes, but I know that you are not following the 100%. I know that. But once you go to, once the class is over, if you try to just copy this code and try to run this code, and after then listen to my lecture and what I was saying, and each line try to understand what I was saying, and then you can get a better feeling of this thing. But at this point of time, try to look what I am saying. Okay. So basically, I am starting with Z dot because I have already told you that if we know Z dot, we can integrate Z dot to get Z, and Z will store nothing but the position and the velocities. So Z dot is R dot and V dot, R dot is R1 dot and R2 dot, V dot is V1 dot and V2 dot. Now R1 dot, this is the rate of change of position vector of M1. Therefore, it is V1, and R2 dot is V2. V1 dot is, that is acceleration of first mass, and it is F1 upon M1. That is force acting on mass 1 divided by its mass. And this is V2, F2 upon M2. You go to the lecture notes which I discussed in the on the onset, you can see that V1, that is acceleration, 1 was F1 upon M1, and V2 dot F2 upon. But again, we don't know what is F1. So F1 and F2 are nothing but F12, that is force on first due to second. Similarly, F2 is nothing but force on second due to first. This is denotation. I have denoted this F21 as F2 and F12 as F1. Now, what was F21? It was Gm2 M1 upon R21 square, and this is that norm of R21. That is the magnitude of R21 cube into R21. Okay, similarly, F12 was Gm1 M2 R12 cube R12. Okay, but now we don't know what R12 is, so I am defining R12 here. R12 is nothing but R2 minus R1. R21 is nothing but R1 minus R2. Okay. Again,
Sir,
going, yeah.
sir, F12 is G M1 M2 by norm. Why norm, sir? Why not simply R21? raised to power 3.
Breaking. Not able to hear. If anybody is hearing him, please tell me. Rashid?
Saying that sir, F21 is G, M2 M1 divided by norm.
Yeah. Now, so
Why,
F12 is G, M1, M2, norm, R12 cube, R12. Yeah. So what is the question?
why sir norm R21
Norm
raised?
means, okay. So norm means it is calculating the magnitude of R12. R12 is basically a vector. So when you write norm, it will, so I will show you here. Okay, let's have a quick. So let us say that we have a vector, what we can say, vector L. Okay, so we have a vector L, and L is equal to 1, 2. So this is a vector, Mustafa.
Yes sir.
So this is a vector. Think that this is the x component of the vector of the position, and this is the y component. And we need to calculate the magnitude of this vector. So magnitude means what will be the magnitude? Under root of 1 square plus 2 square. That is under root of 5.
Yes sir.
Okay, so let's see. So norm of L.
L.
Okay, so you can see. And okay, to check whether this is the square root of 5, I will also calculate SQRT of 5. Okay, so you can see both are same. So basically what norm did, what norm does, it calculates the magnitude of a vector. Okay, under root of x1, x square plus y square plus z square. This is what norm does. Okay.
Yes sir. Yes sir. Clear.
Okay. So this is F12 and this is F21. So now everything is there. Now we require R12. R12 is the position vector of 1 with respect to, and this is R2 minus R1. Okay. And similar. So we are getting a bit late because the last lecture was not there. It was cancelled. So maybe we may take a few more minutes in order to compensate that class also. So okay. That is not only my fault. That was also fault from yours. Okay. R12 is R2 minus R1 and R21 is R1 minus R2. Now again, we don't know what R2 and R1 are. So what R1 is, so think that we had this Z vector, okay. And this Z vector was storing R1, R2, V1 and V2. And R1 in itself was storing two values. What it was, so this is basically R1 is first and second element of Z vector. Okay. And R2 is third and fourth element of Z vector. See, Z is storing your whole thing. Okay. And the first two are R1, the second two are R2, and the fifth and sixth element are V, and the seventh and eighth element are V2. So everything is there. So now we back propagated. This is the back propagation. If you are referring to your notes and you are trying to calculate Z dot, then this is the way you should go. Or you can think it like this. You have this Z vector which is input to this function. So you know what Z is. Z of 1, 2 represents R1, Z of 3, 4 represents R2, Z of 5 and 6 represents V1, and Z of 7, 8 represents V2. Once you know R1 and R2, you can think it like that R12 is R2 minus R1. You will calculate R21 as R1 minus R2. Okay, you know R12 and you know R21, you can calculate F12. This is like normal procedure, how people do it. So we can calculate F12 like this, then we can calculate F21 like this, then we can calculate R1 dot, and we can calculate R2 dot, V1 dot, V2 dot, and then we can calculate R dot, V dot, and then finally Z dot. So from this function, so if what is the name of the function? My state 17. Why I have written this my state 17? Because this was a problem, which was problem on number 17 when I was doing my course. So I have written it my state 17. Okay. There is no other logic. You can write your name for this function. So my states underscore 17. This is the name of the function. I am again saying you can name it by any name. Okay. And it is taking time and z vector and p as the input, and it is throwing out the z dot vector. That is if if you give the time z and p to this function, it will give you back z dot, that is it will give you r dot, r1 dot, r2 dot, v1 dot and v2 dot, and that is what we require. Because if we know z dot we can integrate. So go back to this line. P will give R dot.
Sir,
So this for ODE.
not
Yeah.
not
Yeah.
audible. You are
What?
not audible, sir, for 10 seconds.
Okay, for 10 seconds. Okay, I was saying that from that function, from this function, where is this? So from this function, this function will give us the z dot. This my status underscore 17. This will give z dot. So coming back, where is this? Okay. So my states underscore 17 tzp. This will give me z dot. So this for ODE is nothing but z dot. Okay. And I am giving this to ODE 45. See, I have given it to ODE 45. So what is this? This is nothing but z dot. So now ODE 45 will integrate this function. That is, it will integrate this z dot. For how much time it will integrate it? For t span time. And what is t span? It is 0 to t end. And what is t end? T end we have already defined that for how much time we will be integrating. Okay. And ODE will integrate this z dot, and it will integrate it for this amount of time. But for integration, it need initial conditions. What are the initial conditions for z, which you are trying to, the derivative of which you are going to integrate? What are the initial conditions? So I have put z dot as initial condition. See, this z dot is something which is a vector, and it will contain the initial condition for R1. It will contain the initial condition for R2. It will contain the initial condition for V1, and it will contain the initial condition for V2. So basically this Z naught is a vector, and it is storing how many elements? 2 for this, 2 for this, 2 for this, and 2 for this. That is 4, 6, and 8. So this is an 1 cross 8, sorry, 8 cross 1 vector. 8 cross 1 vector. So this you have to give ODE 45 as input. Once you give it as an input, you will get solution. That is, ODE will give you a solution which will contain the position vector of M1 and M2. And that was our problem. We were trying to get the position vector of M1 and M2. Now we have that thing in our solution. And now that solution is for whole time span. Okay, but I want that solution at any particular instant of time. Deval is that deval does it for me. Okay, when I use deval solution t, it returns me the solution at time t. So this z will now this z will have the R1, R2, V1, and V2 values at t time. But see, I have defined this time as 0 to 1000. Sorry, 0 to t n. So it will store whole solution, this z. Okay. Okay. Now what I want to do, I want to simulate my mass M1 and M2. To simulate mass M1, I need its position. And position, R1 is the position. And R1, the first element of Z is storing the R1. So first element, that is Z of first, is storing my X1. And I have written this column because it will extract the whole vector. Okay, z is not for a particular instant of time. It has created. So you can see. I will. Uh, I can drag the z so that you get some feeling what the z is. Okay, see, this is the z vector. This is at first time, that is initial time. At initial time, you can see z, x1 is this, x2 is this. X1 is this, y1 is this. X2 is this, y2 is this. V1 is this and V2 is this. V1 dot, that is acceleration of first is this, V2 dot, acceleration in second of. This is the value of z at t equal to 0. Then as time proceeds, this is the z vector at first instant of time, second instant of time, third instant of time. So you can see that this whole vector, z vector, is being created for each instant of time. So what does first two elements represent? These represent the x coordinate of what? Mass m1. But you know the mass m1, we have put velocity equal to 0, so this will not move. So you can see with time it is not changing, it is there where it is. But you can see mass m2, it was here at 6000 600 or 6000 kilometers, but it is changing its position. See, it is changing. And also y coordinate, it also changes. Okay, and velocity of m2, you will see it is also changing. Okay, so this is the axis. So now what we are trying to do, we are trying to extract x1, x2, m1 and x2 and y2. So this is what I was this x2, this third row, this represents y2. So we have to make some things. This is what I was uh, saying here. So when I am writing x1 z1 colon, this is extracting the first row. Y1 z2, this is extracting the whole second row. X2 z3, this is extracting the whole third row. Y2, this is extracting the whole fourth row. Is it clear? Uh, can
Yes,
someone
sir.
Rashid and um, Ikra, maybe Rashid first you can. What till now what I am saying, is it clear?
Yes, sir.
Okay, I know that this is a little bit heavy at this point instant of time, but try to follow what I am saying, and hopefully if you do 2 3 problems and animations, each time you will get better. Okay, so I know this is something, this will be something difficult for you, but you have to make some effort. Okay. So now we know x1, that is the x1 and y1, that is the position of m1 at any instant of time. Okay, and similarly, so now we can plot these things. So now this is the plotting thing which I have been discussing for long time. See, this is title which you don't require, don't put it here, you don't require these things. As we proceed, because in each lecture I cannot explain the whole things, then it will take hours and hours. So this is the only reason I am skipping some things which I usually then explain in the next class. So title you don't need, it will create a title, you will see in the animation. Tick, this is a clock in the MATLAB. When you write tick, so a clock automatically starts. And I have defined a variable t equal to 0 and then z equal to Duval solution. I am trying to find the solution at some particular time t. What is the time here? 0. So this initially this z will give me the x1 initial position of m1 and m2, because the time is 0. As the time will proceed, this z will also give me the solution at next time and next time and next. See here the z is 6 cross 1 vector, and each time it changes. and each time you try to extract. I am not using here colon because it is not something a very big matrix. No, it is just a vector. It is storing the value at instant of time and not for the period of time. Previously it was storing the values for period of time. Okay, so now I try to plot x1 y1, that is the position vector of m1. I am trying to plot it. This is the way we plot x1 y1 and dot. How you are going to plot it? As a dot. And b is, please make it blue for me, and mark size it how much big you want this dot to be. So I have written it 300. Similarly, plot x2 y2 and mark it as red, and please make it this much size. Okay. Okay, then we try to plot the trajectory. See, this is only, this will plot the mass m1 and m2. This will plot the trajectory. So x1, y1. Uh, See, I have used dot, so it will create dashed line. Okay, this is the color I am using for the trajectory, and this is the line width for how much thick you want your line to be. Similarly, plot x2 y2. Okay, then x is equal these things you don't require, and then t equal to talk animation speed. See, previously I defined this animation speed. You don't need this, you can put it as 1. But if you want to run your animation very fast, then you can put it 2, 3, 4, depending on how fast you want your animation. Okay. Okay, now I am using while loop. So I told you that when tick starts, this time starts. Okay. And I am writing this time equal to talk. So whatever is the time on the, yeah,
टाइम सर थोड़ा ज्यादा ही होगा
yeah.
सर वी आर रनिंग आउट ऑफ टाइम
Okay, okay. So I will
सॉरी
maybe finish in, yeah, we can discuss in it in the next class. So before stopping, let me play the animation, and then we will again take this in the next. Okay.
ओके सर
Okay, so maybe 2 3 minutes we will take, and then we will. It is because of the last lecture. See, I will have ended this on time, but due to the last lecture we missed. That is the reason. Okay, let's play. Okay, this was all. Let me close it. So are you able to see?
No, sir.
नो सर
Other, nothing is there on the screen.
मैट
Only here, sir.
Oh, I am playing animation. It should be there.
So animation is not visible, sir.
Is it so? For all? Now? Okay,
Not yet.
not yet.
नो सर
Okay, let me do one thing. Let me stop sharing and share it again. And okay, actually, okay, now is it visible?
Oh, yes, sir. Yes, sir. Now it is.
यस सर
So I am actually, I don't know what has happened, but I am only able to share window wise. So this is a different window figure, and MATLAB was a different window. So this is the problem. So actually, this mass started from here, and it was going like this, and then this. So this below is the Earth. Okay, and see, this is the initial condition for mass and mass this Earth, and it is not moving because m1 is very less than its mass. Okay, and this m2, which is the satellite, and it is moving. So you can see this is not a circle. Is it a circle? Hello.
No, sir, it is elliptical path.
Okay. Okay, so it is elliptical, and I have not made it an elliptical. It was just that I put the initial conditions. I see, I put the initial conditions. I throw this satellite here. You can see around 6,000 kilometers and 8,000 kilometers, and after then it start everything happened autonomously. Okay, and this is our inertial frame. So this is the position vector of instantaneous position vector of this mass, and it changes as it moves, it changes. And this was the purpose for this class. So I will play it again. Hopefully you will be able to see. So are you seeing I'm moving?
It's a moving circle cursor.
No, not circle. This red dot is moving.
Red dot is moving. Yes, sir.
Okay, so uh, mm, okay, so one thing I can do is uh, where it is, we can change the initial condition a little bit so that you can see anything happens or not. So let us do what we can do. Okay, let me put this perturbation as 0. Now you can see. So are you seeing? Are you able to see the animation?
No, sir.
Okay.
Yeah. Hello?
No, sir.
Don't know. Okay. I will upload this video and then you can see that for this case, you can see this satellite is moving in a circular path. Okay. So depending upon the initial condition, what are the initial conditions for your satellite? It will have different orbits. It will have elliptical, circular, parabolic, or hyperbolic parameters. It all depends upon what are the initial conditions. So initial conditions are very important things and parameters. So let's stop here, and we will meet next Monday, and hopefully in the the next lecture will be only 1 hour. And today I am sorry, but the whole fault was not from my side. It was due to the cancellation of the last class. Okay. Hope you understood everything. And if there are any questions, I am willing to take, or otherwise you can leave. Have you any questions? Rashid, Ikra, Mutawakkil, any questions?
No, sir.
Can leave maybe 2-3 minutes. He can ask, others can leave. Mutawakkil,